The Koto Research Center, located in Trabuco Canyon, California, is home for one of this country's leading experts in the quickly emerging field of biomechanics, Dr. Gideon ARIEL. Here, surrounded by his arsenal of computer hardware and software, Dr. ARIEL and his staff work to gain a better understanding of human locomotion and the factors that influence and affect movement. The process starts with a combination of high-speed photography and sensor measurements of muscle activity. Sensor measurements are achieved with the use of two specialized pieces of equipment, the electromyograph, or EMG, and the Kistler force platform. Electrodes are placed on the muscles to be measured, and through radio signals, data is sent to the computers where calculations can be easily performed. In the same manner, the force platform is used to measure how different forces come into play as each step or stride is taken. These measurements include the amount of torque and the vertical, horizontal, and lateral pressures placed on each muscle as the movement progresses. Why is this important for a better shoe design? Dr. ARIEL explains.
When we want to optimize athletic performance, or we want to optimize other athletic equipment, or a shoe, we have to rely on science rather than on the guess, because the human eye is very inefficient in trying to see the forces. We have to measure the forces. The field that allows us to measure the forces in biological system is the field of biomechanics. Using a high technology and computer system, it allows us to take a high-speed cinematography, measuring the material, measuring the duration of the step, and that allows us to design an optimal shoes. We want to know, for example, how much shock absorption we want in the shoe. We would like to know how much the shoe should bend actually when you walk in it. We would like to know how much energy is lost and how much energy is recovered. All these factors are extremely important in designing a comfortable shoe. We rely on a high-speed cinematography where we're taking a high-speed film. We rely on force platform where it measures all the forces when a person strikes the ground. We're measuring different surfaces and how they interact with the different shoes, and putting all these characteristics into our computer technology allows us to design the optimal shoe for the person. Instead of putting a shoe on a person, we're putting a person in the shoe. And this is the most important factor in optimizing shoe design.
Once all the data is recorded, the computers are used to calculate and analyze the information. Each frame taken of the subject is used to trace the body's movement. Using a digitizing pen, Dr. ARIEL inputs the position of each joint. From these points, the computer generates stick figures that duplicate the actual movement. This is an important point because a large part of the reason biomechanics is so successful at improving performance, reducing injury, and designing better products is the fact that it analyzes real movement, not simulations. These stick figures can be manipulated to provide a clear picture of how each body part moves in terms of speed, acceleration, and energy output. For Lowell, all of this has come together in the production of a truly comfortable, efficient shoe.
In order to optimize the best shoes, we had to start with people walking, running, jogging, standing, and find what are the characteristics of these activities from a biomechanical point of view. When we learn about that, we start designing shoes with proper characteristics. What characteristics are? The proper shock absorption, the contour of the sole, the comfort characteristics of the shoes, what shape the sole should have. For example, we found out that you need a concave sole, so you will have like a trampoline effect. Also, we want to know how much shock absorption a person wanted in the shoe. We don't want too much shock absorption because, you know, walking on sand, which has very good shock absorption, it's not very comfortable after you walk a mile. Also, going on a hard surface might be very efficient, but after a mile, you will feel your feet. So we needed to compromise between a very efficient a shoe that don't absorb any shock and between a shoe that absorbs too much shock. And we came with a proper design with the proper sole and the contours of the sole, with the proper comfort characteristics, to design the optimized shoes relying on the biomechanical data, on the electromyogram data, on all the characteristics of walking that require. And by integrating all these characteristics, we came with the most optimized shoes available today.